In this tutorial, we're going to talk about how to evaluate inverse trig functions. Before we look at any problems, I want to make sure that you guys know where your answers are going to come from. So we all know the unit circle. We have it in front of us, hopefully, so that you guys can refer to it at all times. Whenever I get answers for evaluating inverse trig functions, I want to stay in a particular domain and range. I want to either keep my answers in quadrant 1 or quadrant 4. In other words, between positive pi over 2 and negative pi over 2. Okay? Of course, on the right-hand side where your x's are positive. So, whatever you have to decide with, always make sure that your answer comes from one of those quadrants. All right. So, when I do give answers in quadrant 1, my answers will be positive degree or radian measures. When I give answers in my fourth quadrant, I'm going to use negative degree or radian measures. So those are the basic rules for writing out answers for evaluating inverse trig functions. So now what we can do is take a look at a problem. So in this particular problem, part A, it says, what is the arcsine of 0? And what it's really asking here is, at what degree measure is sine equal to 0? So in your unit circle, I know that that happens here at 1, 0, okay? And I also know that it happens over here as well, but because that's not where my answer is supposed to be, I'm not going to consider it. So that's kind of nice. So what we have to decide now is at what degree measure is sine equal to 0 here. And the answer, of course, is going to be that theta equals 0 radians or 0 degrees. Okay, part B. What is the arctangent of negative 1? So tangent, of course, is not on our unit circle except in a very hidden, obscure way. So let's try to remember the ratio for tangent. So tangent, in reference to sine and cosine, is the quotient of them. Now, how would I be able to determine where tangent is a 1, let alone a negative 1? Well, in order for that to happen, sine and cosine must be the same. That's the only time where a fraction is ever 1, is when the numerator is the same as the denominator. Now, in this case, though, I'm supposed to have negative 1, so I have to actually pick the quadrant, either 1 or 4, that would give me a negative 1. In other words, in order for a quotient to become negative, one must be positive, the other must be negative, or vice versa. The only place that that's going to happen between quadrant 1 and quadrant 4 is quadrant 4. We're going to be looking down here. Now, the place where the sine and cosine have the same values is actually going to be right here at 315 degrees. Okay. Now, this is only 45 degrees from the x-axis. Okay, and remember what we said about our answers earlier. My answer is either positive answer in quadrant 1 or negative answer in quadrant 4. So this in actuality is a negative 45 degrees. So just to make sure that you understand this, at 315 degrees, that's where cosine is positive square root of 2 over 2 and sine is negative square root of 2 over 2. And when I divide them, I get negative 1. So that's where that negative 1 comes from. So I can say my answer in one of two ways. I can say that this happens at negative pi over 4 radians or negative 45 degrees. Okay, let's take a look at one more. So this is also asking for the inverse of sine at negative square root of 2 over 2. The notation of arc, tangent, arc, sine, arc, cosine is the same thing as using this little negative 1 as an exponent. It's not technically an exponent at all. It's just the notation that this is the inverse of sine. So again, we're trying to look at either quadrant 1 or quadrant 4 to where sine is negative square root of 2 over 2. Obviously, we are not going to get any positive y values in quadrant 1. So our answers must be coming from quadrant 4, which means we're going to have another negative answer. So actually, when I look at the previous problem I just did, when I look back at this angle here, at that 315 degree angle mark, aka negative pi over 4 or negative 45 degrees, that is actually where my y value is at negative square root of 2 over 2. So when you look on your unit circle and you see the coordinate, it should be positive square root of 2 over 2 and then negative square root of 2 over 2. So again, this is where sine is equal to that value. So my answer for part C is actually going to be the same as it was for part B. So theta is equal to negative pi over 4 or negative 45 degrees. And we're going to do one more and then we'll be done. Alright, so last one. So what is the inverse cosine of positive 1? So again, we have to look at a unit circle and figure out where my cosine value is equal to 1. I actually already have one listed right here. Okay, so that's where cosine is equal to positive 1. That's actually the only place on this entire unit circle, besides 2 pi, that cosine is equal to a positive 1. So that one was pretty easy. We can just go ahead and list that answer out because that means that theta is either 0 radians or 0 degrees. And that will conclude this tutorial.